Go through that stuff first, then the kite. And then on top of just the definitions of them, they both have specific properties that come about it. And then there's one thing with the trapezoid, which is the mid-segment, that will require a little bit of work. But it's going to be similar to the triangle ones we did. Okay, so first one. By definition, all a trapezoid is it's quadrilateral, and it has a pair of parallel sides. One pair. If it had more than one pair of parallel sides, it would be a parallelogram. So basically, if you want to think about it as like a parallelogram with one pair of sides as opposed to two, that's fine. The sides that are the parallel sides are the ones that are going to be considered the bases, which you need to know in terms of identification process. When they give you directions and they say the bases of a trapezoid are 10 and 12, you would know if you had to draw a picture, the two sides that you had as parallel would be the 10 and 12. And then the other two sides are just called legs. Okay? And there's nothing special about the legs in a regular trapezoid. It's just trapezoid. If there's anything else to it. Okay? Now, if you have the legs being congruent to each other, this is, when we did triangles, I said trapezoids, when we got to them, are going to be very similar to a triangle. So that if these two sides end up being congruent to each other, you would call it an isosceles trapezoid. Just like with an isosceles triangle, the legs were congruent, same thing goes here. The other one is a kite. So a kite, similar to a parallelogram in the fact that it's got two pairs of congruent sides. The difference is now the opposite sides are incongruent. It's going to be the consecutive sides that are congruent. Okay, so by definition, for it to be a kite, all you need to see is two pairs of sides being congruent, but they just have to be not opposite each other. Okay, because if they were opposite each other, you'd be back into a parallelogram, which is not what you'd want to work with here. The properties. Okay, so we'll start first with the trapezoid. Okay, so first thing. The thing that says the angles of the legs are supplementary. That's the only additional property. The other one's the definition of it, but since the definition involves things like parallel lines, I mark that as a separate property. Just because anything we've ever talked about with parallel lines could apply here. The angles on the legs, what I mean by that is if I had this as my trapezoid, when I say the angles on the legs are supplementary, I'm talking about here's a leg, this angle and this one are on the same leg. So I know that A plus B has to add up to 180. And if you really want the reasoning behind this, this goes back to chapter 3. Those are same side interior angles. Same thing would go here. This is another leg, so C and D are also on the same leg as each other. So that means that C and D also add up to 180. And that's it. Like with it just regular old trapezoid, there's nothing else you can bring about. Okay. The isosceles ones have a little bit more involved. All right. I just wanted you to draw this maybe so you can specify and understand which two I'm talking about when I say the ones on the legs. They have to be the two angles that are on the exact same leg. Okay, so you don't want to go across this way. You want to go like up and down the legs. And if it was turned sideways, it would still apply. Like if that was my parallel sides, that would still be a base. So that would be like B and A, and that'd be like D and C. So there's your leg, and there's your leg. Got a little bit more. Obviously, for it to be isosceles, the legs have to be congruent. So again, that's the definition, but since congruence is kind of like a property, I listed on here. Base angles. The base angles are just the two angles that are on the exact same base as each other. So just like with the legs being supplementary, again, I count like the bases as the ones that are on the same base. And then the diagonals have to be equal to each other. And again, remember, diagonal just means that you're connecting vertices. So it's a diagonal is just a line that connects the vertices, but it has to pass through the inside of the shape. Okay. So if you were using the figures right here, they have the actual properties in order of what's over there. On this one, you can also add A and B are going to be equal to each other. So if you're dealing with an isosceles trapezoid, you'll know like these two are equal, these two are equal. And also from the original thing, you would know these two angles add up to 180 and those two angles add up to 180 also. So the one thing is the diagonals are going to be perpendicular, which means that you're going to have right angles in here. This one is kind of like the same as with a rhombus or a square. And then the other one, the first one up there says exactly one pair of opposite angles are congruent. The opposite angles that are always going to be congruent are going to be the two angles that are formed by these sides that are not congruent. So like this side and this side are not congruent, so this angle and the one opposite it would always be equal. So that if I like had the picture turns the other way, like this, and I said those are equal and so are those. If I saw a kite like this, I would automatically go that angle and that one are congruent to each other. These two are not going to be congruent. If these two would end up being congruent, it wouldn't be a kite, it would be a parallelogram. Okay, so kites only have one pair of opposite angles congruent, but at the same time, also remember that all four angles add up to 360. Like, don't ever forget that kind of portion either. Here is the same as what we have with the triangle. Mid-segment just meant it's a segment that connects midpoints. Again, same as what it was for a triangle. We just have a different shape here. Okay? If you remember, when we did it with the triangle, a mid-segment ended up being parallel to one of the sides of the triangle, and it also ended up being half the length of that side that it was parallel to. So the same thing is going to apply with the trapezoid. So when we did this, just going to remind you, when we did this, guys, with a triangle, if I had a triangle and I drew that mid-segment in there, the two properties we had was that they were parallel, and we also said like if this was 10, this one was half of it, which was 5. You're going to be doing the same thing with this one. The big difference between a trapezoid and a triangle is now when I look at this segment here, I'm not just looking at one side. I'm still going to be concerned with the sides that are parallel to it. But like if I put a number here, like give me a number here. 6, and then give me another number. 13. 13. Give me an even number. Like 14 is better. 14 is better. Like if I said, okay, apply kind of what I figured out here, where I said like this part's half a 10 to what's here. You can't just go, oh, it's half a 6 or half a 14, because I don't know which side I'd be looking at. So as opposed to like a triangle where I take half of one side, now I'm kind of taking half of both the sides. Such as, what's half of 14?
7.
What's half of 6?
3, 5, 10.
So it's 10. But it's the same kind of idea. It's still in the middle. It's half. It's just half of both of those sides combined together. 1.
25.
Right there. With 25, fine, I'll do 25. Alright, so this would be like another kind of problem. Okay, so like the first one I just wrote up there was I found the mid-segment. I gave you like the two bases, and I said you take half of those and add them, and you can get the mid-segment. So this is kind of the same idea, but now it's like in reverse. You don't really need to set up a formula for this if you understand that this line is directly in the middle between these two. So if you think about it like a number line, it's usually easier to work with. Meaning, this thing is in the middle. So if I go from 25 to 21, how far apart are those numbers if I put them on a number line? Huh? 4. So it means that for this line right here to be right in the middle, these two also have to be spaced out the same distance. Okay? If I did this with work, like if I did it with that formula, it would look like 21 equals 1/2 x plus 25. This would be what it would look like if I set it up with what's there. So you would like multiply by 2 and then subtract 25, and you would still get the same answer.